throw the first slide up. So just real quick, show of hands. How many folks feel this whole, we're living in an age of acceleration, everything's going faster? Right? Everybody pretty much believes that way. How many folks like to go fast on water? Right? We're in the Chesapeake area. Everybody likes, right? Next slide, please. If I told you that this is the way we were going to do it soon, right? I think you'd all say, that looks pretty good, right? We'd be going real fast. And I think this is exactly what you're going to find happens. If you're in the networking space, get ready, because it's going to be a really interesting ride. People study this stuff all the time. Next slide, please. And what you're going to find is, if you go back and look historically, this is not the first time we've faced, substantial change on the industrial front, on the technology front. It just turns out every time we do this, it gets faster and it gets taller and it has more implications. Next slide, please. In fact, you can say in the digital networking space, we're kind of at the beginning of this third wave, right? You saw the internet come into place. You saw email. We then gave cell phones to folks, right? Connectivity. We're now at this third wave. This is the intelligent internet. This is the beginning of this Internet of Things, and that drives a whole different set of requirements back into the networking space. And they're coming in from all different directions than what we would have had just a few years ago. Next slide, please. So what I've done is cut the talk into two pieces, a little bit on the driving forces, right? Force, mass, acceleration, right? We're accelerating, there must be force involved. And then how do we keep up? Because there is so much change going on. What do we have to do in the industry from the network operator's point of view, what you do from the equipment vendor's point of view? Next slide. And this change shouldn't surprise us too much, right? The basic nature of connectivity is changing quite dramatically. When we first put networks together, really what we were doing was connecting places. And you can argue, in rough numbers, about 500 million locations that you can do this to. Connecting people, some number of billions. The thing that really drives this ultimately is the connections of the machines. And if you go even further, the fact that you can put virtual machines on top of physical machines, just think about the number of virtual machines sitting inside of your smartphone, a virtual machine for a GPS, for a calendar, for all different things that you used to have physical devices for, right? You're not carrying digital cameras anymore, you have your phone. You're not carrying a stopwatch anymore, you have your phone. Think of all those virtual devices, they can all communicate, right? That's what's driving a lot of this. Next slide. And there's been just tremendous change. Let's build this one out. We have a traffic pattern to show. So when the internet was originally created, what we did is we basically connected endpoints. Okay, we're going to connect a network, we're going to interconnect networks. All that's changed. Next slide. And let's build that one out also. So with hypergiants, and this was a term that was coined, it was actually the folks at Arbor Networks did this at one of the NANOGs. What's occurred is there's actually destinations that in the cloud you want to get to. In fact, once you get there, you tend to stay there. Once you get to Google or Amazon or Facebook or Apple or all these different places, you tend to stay there for a while, and that drives just huge changes in traffic patterns. We first saw this in the expansion of the metros. All of a sudden, people wanted to connect from users to content. They weren't just connecting users to users or endpoints. They were connecting users into content locations, and that drove traffic patterns way different than what we'd seen before. Next slide. And so you can argue that networks today are being reimagined like never before. Right? People are all over the world looking at what we can do with networking from a whole different perspective. You've got the emergence of IP as that's your world's addressing scheme. Ethernet, that technology accomplished things that no other technology did, right? SONET, SDH were different. I don't have T1s and E1s anymore. I have Ethernet. It's the same everywhere in the world. I can take a trip anywhere. If I have an Ethernet connection, chances are I can get on net. And the rates for all this have gone up as well. What was 1 gig is 10, what's 10 now is to 100. And if you're a user of all this, you've observed real convergence, right? The concept of saying, well, look, I'm on an enterprise network, I'm now on a commercial, I'm on a residential, all that's blurred. What you were after is the same consistent user experience throughout, wherever you go. You get on a plane, you want the same experience as when you were off the plane. You get to a different country, you want the exact same experience. You get into a hotel room, you want the same experience as if you were sitting at your house. Now, you can't always get it, but that's what you want. That's where you want to go in terms of your network services. So next slide, please. And you see what this does to data center capacity. This is just some of the information that Google presented at their plenary at OFC beginning of this year. You can see the growth in the intra data center. So this is within the data center, right? This is communications within that data center. But keep in mind, this is what drives people wanting to get to it, right? The fact that there's information, there's knowledge that's inside of that content center, that's what drives your interest in it. You want to get to it. Well, 50x increase, just a countable number of years. Dramatic changes. Next slide. Let's do this one.
It's whatever you would like to change to.
Why don't we do this guy?
Okay. How the heck did that happen? Okay.
I'll trade you. Hit it without too much English. Is that better?
Yeah.
Is that one better?
Yes.
Is that a thumbs up? That's better? No, here's not on. Not on yet? Testing 1, 2. All right, here. We'll try the master power reset. How's that? Or if I can contain myself, I can stand here. Would that be better for everybody? Let's do this one. What's up on the screen here was an interesting observation, right? This is from the guys that are actually really good at this. This is Google, their cloud store in Pokemon Go. If you look on here, the bottom line was the original launch target of what they thought capacity would have to be. The estimated worst case, and look what really happened. Right? Now, I figured this out when coming home, taking my kid home from school one time. And look, these, normal high school kid, right? He does taekwondo, he does tennis, he gets in the car, he turns into a lump. But you're driving him home, and he stops me, and he says, hey, I'm a mile from the house, we're getting in the neighborhood. He goes, hey, Dad, I want to get out here and jog home. I'm like, jog home? Are you kidding me? You're going to jog home? You never jog home. He goes, well, I'm going to jog home. Well, out comes the phone, and what he's doing is he's catching Pokemons as he goes. So it was pretty clear that this thing was going to be a major effect going forward, and it was, right? 50 times more than what people thought. So that's the impact of things when they go viral, as like people like to say. So next slide, please. So what are the content guys doing? Well, they go build their data centers to accommodate this, and they go global very quickly. This is some information that comes out of telegeography. These are the guys that track where capacity is, where connectivities are, and such. And you can see very quickly, the big players here, Amazon Web Services, Apple, Facebook, Google, Microsoft, they're growing internationally. And that drives now tremendous amounts of capacity across those backbones. Because think about it, right? We're building connections user to content. Well, now they own the content centers, and they're building connections that are content to content so they can replicate and they can interconnect. Next slide. And in fact, if you look at Amazon, this is a good example of their network that they're publishing, right? 100 gigabit Ethernet network circling the globe for them to do their business, right? You can find carriers that don't have anywhere near this kind of capability, right? But this is the Webscale, this is the hypergiant. That's what's driving a tremendous amount of what goes on in our industry now. Next slide, please. To the point now where, for the first time, you have Webscale folks who are partnered up, here's Facebook and Microsoft, putting their own submarine cables in place. This is Maria. But what I wanted to point out on here is 160 terabit per second capacity. And that's not going to be enough when you look at where they really want to go. All right? But you just have to stop and think about what that means in terms of total capacity and connectivity compared to what we're used to thinking from a carrier space. Next slide. And so it's very interesting to kind of speculate on, and this is some interesting projections of an outfit Light Counting that tracks what's going on in the business space. This is the total spending and the revenues associated with both the largest communication service providers and the internet content providers, the ICPs. And the thing to watch here is those are crossing. All right? So if you follow the golden rule of he who has the gold makes the rules, you can find a point in time where the driving forces for telecommunications, communications over distance, wide area networking, is going to be more the cloud folks, the content providers, than it may be the carriers in the future. So it's an interesting change in the dynamics of the industry. Again, hasn't happened yet. These are all projections. But again, it's an interesting thing to speculate on when the majority of the capacity comes from the web scale owners, as opposed to the carriers, which it has for generations. Next slide, please. And this shouldn't surprise us, right? If you look at the total statistics on the planet, this is a pretty good snapshot from the folks We Are Social. They look at it on a global basis. The thing to take away from this slide is compare the population to the number of internet users, about 50% of the population's on net, and then look at the number of mobile subscriptions, right? It's actually greater than the total population. So there's more machines talking on the network now than there are people on the network. So that's your Internet of Things. Next slide. And if we double click on that and say what's in the US, exact same kind of phenomenon. Back up one real quick if you would. So there we are, 108% US, and we have a much higher overall internet penetration rate. But it still gives you a sense of what's going on, what the driving forces are in the business. Next slide. So here's where we are. We are in an absolute on-demand, app-driven world. That is what everybody wants. Next slide. And I'll give you a very simple example of why the network needs to change. You can go online today, and AWS is a good example, there are many others, and with a credit card, you can order up pretty much as many processor cores, as much compute resources as you need, as much storage resources as you need. What you can't do is order up the network to take advantage of it. To get the network to do what you want may take weeks to months, if you can even get it at all. And therein lies the fundamental challenge and problem in the networking space, is how do we make the network catch up to what we can do in the compute and store side of the house? So next slide. And if you're in a service provider business, this is what excellence means right now. It is all about on-demand. Odds are there's an app for whatever your customers want to do. It's all about efficiency. It's about cloud bursting. It's all about being able to do it now, right? And now is the new cheap. Now is the new everything, right? It's all about getting services immediately. It's the same dynamic as when you pick out your phone and you go, where am I? I want to send a text message. What's the weather? What's the stock? What's the news? It's that kind of an environment wants to be created for the networking space. So next slide. So how do we keep up? Let's keep going. Next slide. So if you're in a networking business, you're going to be doing one of these things. You're going to be providing either more or smarter or faster. And more is going to be capacity, connections, capabilities. You're going to have smarter architectures. You're going to have smarter ways to scale. You're going to have faster implementations, faster time to revenue, faster time to mission completion, faster time to restoration. All that is what's going to be required in the networking space. Let's keep going. Next slide. So even at the edge of the network, people have figured this out, right? Ethernet, which used to be kind of, the slow LAN speed, okay, it's going to go to a gigabit, maybe 10. All of a sudden now there's roadmaps out there for 25, 100, 400, all the way out to the terabit per second speed just for Ethernet, that wonderful edge of the network LAN technology, Ethernet at terabit rates. Next slide. This gives you a sense of where things are going just from shipments, right? So again, these are the folks that track what's actually going on in the business. You take a look at 2017, where we are today, that's their crossover point between 100 gig E and 40 gig E. Right? So 100 gig Ethernet is going to turn into kind of the standard unit of currency for high capacity bandwidth here very, very shortly. And you can see the beginning of the rise of the 200 gig and the 400 gig coming in. And where they're going first, they're going to the Webscale folks. They're going inside of those data centers, inside of that area where they need to scale the most. Next slide. And we've contributed to this ourselves. This is a WaveLogic technology that we use on the long distance lines. That black curve that you see on there is a generation old technology about 3 years ago. The blue line on there is the one that we've just introduced. We call it WaveLogic AI. Improved granularity, a lot more programmability. There will be other generations of it, and that staircase will fill in. Right? Where the networks are going to go to is you're going to signal as fast on that network as the physics allows. These ideas of having fixed rates of I can only do 100 or 400 or 800, that's all going to go away. And you're going to program your physical layer to go as fast as the physics allows because you need it to be able to support the demand for capacity. And that's exactly why we're doing what we are with WaveLogic. So next slide, please. And if you go out to the edge of the network, 5G is a fascinating set of changes that have been put in place. If you think about what is going on here, right, user experience data rate up 1,000 times, 3 orders of magnitude. A very simple way to get your arm around this thing is to say, look, the edge of the network today is roughly gigabits in first order. I can take a gigabit to any building I want, generally speaking. Think about taking a gigabit to every handset in the world. That's what 5G is really targeting, right? So you're going from those, let's say, countable numbers of 500 million locations in terms of buildings, now potentially 5 billion locations if I can put them onto individual handsets. Reductions in latency, improvements in efficiency, but dramatic improvements in the edge of the network speed. Let's keep going. Next slide. And the processor guys are keeping up. This is out of Qualcomm with Snapdragon, right? Looking at 1 gig edge speeds. Next slide. Internet of Things, application spectrum, very, very broad. You've seen slides like this probably for the last several years. Everything from wearables all the way out to the edge in terms of, smart trains, smart cars, self-driving, everything. Getting back to my comment earlier, there's not going to be self-driving jet skis. People like to go fast. You're not going to have self-driving motorcycles. You want to go fast. Car, maybe, right? You want to get in it and just get someplace. But let's go. Next slide. This is one that I think is kind of interesting. 10 billion products to be born digital. They're talking about clothing. Okay, now some of this is just as simple as QR codes on things, but there's a huge drive out of the high-end clothing industry to identify points of origin. Right? Another slide, please. Here's a very interesting one, electronic thread. Right? This was from a workshop that was done at a venture capital forum I was at last year in Europe, where a couple companies have come up with a way to build RFID taggable thread into a normal manufacturing process. So it's nothing you add later on, it just goes into the normal fabrication of the clothing. And of course, all of a sudden now people are saying, I can build sensors, I can build displays, if I can power it. Lots of things come from these kind of concepts. Next slide. So this kind of sums it up, and these numbers are so big, I'll admit it's hard to get, to really wrap your head around this whole thing of saying, 50 trillion gigabits of data and, 20 billion things, and this is only 3 years out. Will we be right or not? Don't know, but this is the kind of, projections, if you will, about the capacities and the numbers of devices that are going to be required. Next slide. And it has pretty dramatic implications for what happens in terms of the networking space, mostly along the line of the bottom, where does content really go here? Because it can't just stay in centralized content centers if what you want is microsecond and millisecond class round trip times. And that's what's required to close control loops and make things intelligent and be able to say, if you're in a car, oh, by the way, there's somebody coming this way, you better stop. Right? So that's a whole different way of looking at what does mobile edge compute need to be and where does computational resources go. But it is that combination of connect, compute, and store that's really required. Next slide. So all of network infrastructure is being reimagined right now. Right? We're saying, I don't want data centers, I don't want things to be inside central offices, I want them to be inside of data centers. I don't want bolt-on appliances, I want them to be virtual network functions. Let's go to the next slide. And software is absolutely disrupting the network. Most networks that we've ever built were on the left-hand side here. You bought them from 3 different vendors. I've got them color-coded into 3 different possible sources. You would spend a lot of money on an OSS, BSS side to integrate it all together to make the thing work kind of in a holistic sense. Guess what? All those things in the middle came out of the Webscale world. Massively scalable databases. Super reliable communications infrastructure in terms of message passing between applications and such. Why? Well, guess what? Folks like Twitter needed things, Facebook needed things, Google needed things. You can start to build applications based off of those architectures and reimagine what the network needs to be. Next slide. And it gives you a chance to even reimagine what the service provider is. And we see people doing this now, saying, okay, the old model was I would take equipment and I would rent or I would sell you ports so you can connect. That's the best I could do for you. The new model is I'm going to enable your business because I'm going to give you a platform that you can build on top of, right? I'm going to build you a programmable platform. That's how folks like Netflix came to market. Right? If you were doing Netflix 10 years ago, you would have been running coax down neighborhoods counting how many homes passed. Today, the Netflix business model or any of these business models is pretty simple. It's how many eyeballs are on the internet at any given time. Right? Dramatic changes in what addressable markets looks like because they sit on top of this programmable platform. Next slide. And this, to me, fundamentally is probably the biggest driving force out there and the biggest reaction that's going on is we're taking the best of the IT technology, we're taking the best of the telecom technology, and they are converging. And they're taking us from this old world where we would take transport infrastructure, we'd layer on top of it packet infrastructure, and then we'd start bolting all these different appliances together to build up a network. We're saying, no, that's not how it's going to be built in the future. We're going to have converged packet optical. It's going to be integrated in functionally with the compute and store resources sitting above it, virtual network functions, orchestration sitting on the top, analytics coming up telling you what's going on, informing orchestration what it has to do, and then SDN coming back around and saying, okay, here's how the network needs to react to what I'm seeing through the analytics side of the house. Next slide. And so the network ultimately becomes this programmable platform. It is literally the same operating model as you have today when you drop an application onto your iPad or your smartphone. And all of a sudden it turns into a television or it turns into a typewriter or it turns into something else. That's exactly what we want the network to be able to do. Enable it as a programmable platform. Next slide. So here's a simple example. An app that does partitioning. Why partition? Different missions. Commercial side, I might be covering the World Cup or the Super Bowl. I don't want anybody playing in my network over here. I'm going to partition it, and you can't get to it. Next slide, please. You may have applications that follow the sun, right? During the day, you may be connecting up 100 gig E between some locations. Next slide. And in the evening, guess what? You're doing backups over fiber channel. Same network, different application. All you did is program it differently. Next slide. And ultimately, you get to the point where you can slice networks and you can do things differently. You can offer different portions of the network to different missions, different applications, different users. This is where 5G needs to go as well, where you can say this portion of my network is connected car, has a certain set of requirements. This portion of my network are the folks who are streaming video, and this portion of the network, that's just regular browsing, right, where you can basically partition all those resources to do it. Next slide. The way you stitch it all together is the multi-domain service orchestration piece of it, right? You go through whether it's something that maybe we built or another vendor built. It's been in legacy for a long time. It may be something that no one's thought of yet, but as long as it has a well-defined interface you can talk to, that you can script to, they can understand what comes back, this is a very good way to do it. That's your orchestration piece. Next slide. So I want to just quickly run through a couple of simple case studies. This is Orange Business Services. This is one where, in fact, we don't provide any of the hardware. We just provide a software solution, and they're orchestrating a bunch of legacy equipment. And it is just that. You write resource adapters for each one of the network elements, and then you orchestrate it across the top according to templated services, and they can replicate services very quickly. Next slide, please. Here's another one where it's SDWIN, and they're using this to adjudicate between what sits on MPLS, what sits on general purpose internet. Right? It's a great way to reduce costs because a lot of the traffic, you know, if you got somebody who's out there, you know, taking online training and it's just streaming video, does that really need to go over, you know, the high value, high cost MPLS infrastructure? In many cases, no. Right? And this way you can start to partition things, you can start to slice things, but you do it in an orchestrated sense. Next one, please. Next slide. Here's a really interesting one that we've shown off a couple times, and you can see some more of this at the Ciena truck. You can treat anything you want as a domain. You can treat ground assets, you can treat space assets as a domain, but you can see them all in one location, and you can orchestrate them together. Here's a great way to see that, right, where you're actually integrating the satellite network with the ground and terrestrial network. Next slide, please. And way you get to real benefit here is when you can combine the orchestration and the analytics with visualization and see what is really going on in the network. That's one of the keys. Next slide. And the thing to understand about analytics, and it gets used a lot, but fundamentally what analytics is about is understanding what's normal. See, in a networking space, we actually don't know that. What we know is it alarmed or is it not? But we don't know that not alarmed is actually normal. We just know it's not alarmed. So let's go to the next slide. I think you'd find it kind of interesting to know if there was something in your network that was doing that slope. Okay, this is kind of the equivalent of saying, you know, it's not just an idiot light on my dashboard. I happen to know what the oil pressure is, and for some reason the oil pressure is going up or the temperature is going up, and I haven't reached critical yet, but something is changing in my network. That's really the way I think you should think about analytics from a networking point of view is, what is normal for my network? Because you have to know normal to figure out abnormal. Next slide, please. And the ability to visualize is critical, right? We know lots of networks today, even some of the major tier ones, when they look at what their basic fundamental resource is, capacity, it's an Excel spreadsheet or it's a notebook. And there's no good way for them to visualize what they've actually got and what's actually in use. So changing that with analytics we think is key. Next slide. And we do this on a research and test bed. I can't say these are all commercial products. This is kind of forward-looking where we think things are going. So we have established our own, and this is a good example of collaboration, right? Canary, ESNet, Internet2, Starlight, Ciena. Starlight is a hub into lots of the R&E networks that are global. But it gives us a sandbox, a place to go and play with some of these ideas that's safe. Next slide. Networking equipment that sits in it. Next slide. And one of the things we've built with this is what we call SARNet. It's a security autonomous response for programmable networks. Next slide. And what we've built is a real-time control loop where we can look at what the network's doing and detect anomalies, right? Get back to this idea of saying, I've got analytics, am I normal or am I not? Next slide. What we're going to do now is run you a video of how this kind of network behaves. And it is exactly a network under attack. We're going to show you a couple different attacks and how this kind of a network that can use analytics and also deploy NFVs and SDN can respond to it. So first one, classic denial of service. So left-hand side, they're the bad guys, right-hand side are the good guys. And what we're going to do is we're going to start the attack, and what's going to come up in the middle are some of the analytics that we're watching. You can see the flood that comes across. And what you're actually looking for is changes in behavior. Okay, and what you're going to see is all of a sudden the metrics of the application work drop off, successful transactions drop off, login attempts drop, people can't get anywhere, then the network responds and it restores. And it did that by pushing a bunch of virtual functions out to the edge and saying, okay, I've identified where all your traffic's coming from, and I have throttles on UDP and TCP, and I can adjust rate, I can throttle you down. Okay. So it was that ability to rapidly identify, go out, and it basically stop the attack. Next one is password attack, brute force. Again, bad guys on the left, good guys on the right. This is harder to detect in the networking space because it isn't a flood. So again, you have to look at the analytics. Right? You can't really see it at the network level. So what you do is you look at, okay, how many successful logins have I got? How many fails have I got, which is that bottom curve? And all of a sudden, wow, there's something going on. Right? So I can take all that traffic, I can route it to an intrusion detection container, then I can take it off to the side and I can stick it in the honeypot and go watch and see what these guys are up to. But again, it's the ability to have, clearly identifiable analytics that say this is normal and this is not. Okay, because it gives you a sense of how quickly these things can be done, right? And we've created these networks where you can attack them in milliseconds, but it takes us a while to figure out what it is, when we respond in hours kind of thing, right? And that shouldn't be that way. And again, this is a great example of collaboration. This one was done with KLM, an airline, major airline. Airlines get attacked all the time. University of Amsterdam, where we had some folks that were very interested in it. And I would love to tell you that we can stay with just the layer 3 and above sort of attack scenarios, right? These standoff attacks. I think the reality is we can't. There's been some very interesting, as you want to call them that, research activities from locations. Propagation of all optical crosstalk, physical layer attacks in transparent networks. Once you're in the network, especially when you have these kind of capacities, you can do a lot of damage quickly. And so there's people who are actively out looking at these kind of studies now. This is stuff that, historically I never saw published in from US researchers, but it's coming from elsewhere in the world. So it gives you some interesting what ifs. Next slide, please. So this, I think, is a great example of collaboration. If anything, I think if you allow me to put an ask into this presentation, the ask is to do more of exactly what you see on this chart, right? I think we've had great success ourselves, industry and academia kind of collaborations, with the smattering here and there, the government side of it. I would say, look, we're all in this together, right? We are all trying to keep the dark side over on their side of the world and keep them at bay, as it were. I think there is an opportunity for substantially more collaboration on exactly these kind of activities. So next slide. I do want to thank our partners. We call them part of the Blue Orbit in terms of how they interact with our product lines and stuff. We have them on DevOps, on technology, on services and stuff. So just an acknowledgement to our partners. A lot of the work I showed you is also with those folks. And last slide, if you will. I just wanted to leave you with this one. It's interesting. It really, all it says is, for us to continue to survive and thrive in this age of acceleration, we just have to be adaptive. We've got to be most responsive to this, right? This is often attributed to Darwin. If you do a little double click on it, it might have been written about him as opposed to quoted by him. It's kind of interesting just how these things get created, but I thought it was an interesting quote. So with that, last slide, I believe, and it's a thank you. Thanks for your attention and interest. All right.
We have some time for some questions. The first question for you, sir. Are networks being designed with an eye toward robustness and resilience, or just primarily focused on capacity and speed? Do you believe ubiquity will serve as a substitute for resilience?
So it's actually a very good question. The short answer is both, right? We still see people who, first and foremost, will give me capacity first, and if it fails, well, it fails. But we know there are better ways. And what we try to do, and this is true even on submarine cables if you think about it, right? If you're putting 100 terabits across the ocean and somebody drags an anchor and that cable goes down, what do? That's so much capacity, you better have resiliency and backup. And what you find is you will build them to be much more distributed, much more meshy, right? The ideas of just 1 + 1 or even 1 for n protection aren't nearly as attractive as saying I have a mesh capability. I can weave my way through many, many different routes. I think the protection issue is actually very interesting, right? One, I didn't say it earlier, but if you think about the reluctance that people have to build autonomous networks to respond to attack, It's largely because we don't understand the signature of the attack yet. We know pretty well the signature of a failure from a reliability point of view, availability point of view, right? The signal's down, things are in alarm, people are running around the NOC with their hair on fire, pretty good signature, there's a problem. We need to be able to get that exactly on the attack side also. How do we understand the signatures of normal and not normal? Next question.
Where do you see the greatest business opportunities in the rapid expansion of demand capacity? Is it in the nodes or the network?
Let's see. Where we see the greatest growth, let me answer it that way, is actually coming out today from network operators that are building out in places like India. There's tremendous growth in China also. We have no business in China, so we'll just keep that separate. India, for sure, I think you've got a government in place that's kind of pro-infrastructure in some ways. They don't have programs in place. They're letting the operators do that. But you've got a population that's a rapidly emerging middle class. You've got a thirst for content. You've got Bollywood that creates a tremendous amount of video content and entertainment. You've got all the right mix for a great success there in terms of total capacity. The Webscale folks are focused on what happens in my data center and then how I connect to it very efficiently. So you can look at them as driving data center, which would be future central office technologies, and you can look at the operators that have wireless assets as driving very hard for 5G, Internet of Things. It's a way for them to get back in the game in some sense and offer you more than just a connection, but offer you value-added services on top of that. Okay.
Thank you. Could you address the demands of cybersecurity as a constraint on this rapid expansion of networks and demand?
Well, I would love to tell you that everyone's first thought is security, and we know better. It isn't, right? Security is very often an afterthought on these things, and we've seen it multiple times. I think the great promise around things around SDN and NFV, although it also scares folks because of the changes in the attack surfaces and such, is the rapid speed at which you can do things. The video that we took you through where the network really did respond in a few seconds to a pretty substantial attack is a pretty good indication of where this can go. And so the reason I'm so interested in the collaboration is the security is more top of mind inside the government space, absolutely. It is not nearly top of mind the further out you get. And in the middle, in the commercial world, and in the middle is the academics who are interested in it almost purely on an intellectual point of view. How do you attack and how do you defend? And that's why I think that three-party group, right, having all three work on the problem together actually will get us the best result, because I think we can define architecturally how networks should be built so they can be assured and secured better than we do today. I think there's lots of room for improvement.
How do you see net neutrality impacting the growth of the net?
So it's interesting what net neutrality means, right? It's a bit of a U.S.-specific concept, and I think most of the operators have sorted out that while they would like to give some sort of, preference to things, they also know they need to be successful over the top of other people's networks. And so they look, I think, at net neutrality as something that they want more levers on than just saying everything is, plain vanilla and everything has to be treated the same. At the same time, they know that, and this is true, I might be a subscriber of, a Verizon service. Well, I might be, roaming and be on an AT&T or a BT network. I'd like the same experience. And if I was the provider of that, I would like me to have that. The last thing I want to do is have my customers leave my environment. Right? Because once they leave my environment, well, they might find something else they like, or just why would I introduce that risk? Right? I want them to stay on my environment as much as possible. So to be successful, they have to be as good over the top on someone else's network. So that kind of is a balance to this whole argument around, the net neutrality piece, I believe.
That was our final question from Mr. Alexander. Okay. Please welcome Lieutenant General Bob Wood back to the stage to formally thank him on behalf of AFCEA and our audience.
Thank you very much, Steve. We appreciate it. Let's give him a hand. I can tell you, you know, we're talking to a true expert here. Thank you very much for that presentation, and really not only where we are, but where we're going in network and network capacity. Good questions. Thank you for that. What we are going to do next is transition, and we'll do that after we do a setup on the stage. Steve, I would tell you that on your behalf, we're making a donation to Fisher House for thank you for your time and for your expertise. Let's give her a hand again, please. So next, I'd like to, as we start to set up, we're going to invite our panel presenters up here. We're going to set up the panel on stage. You're welcome to take a short, quick break here in place because we're starting right up again as soon as we get our panel set up. We will have a networking break on the exhibit floor at 1 o'clock. During the networking break, the final set of theater sessions will be presented. In addition, the Cyber Innovation Pavilion in the 100 aisle of the theater spaces is presenting some more cybercom content. And today's luncheon will feature, our speaker will be Dr. Zangardi, acting DoD CIO. At lunch, AFCEA again invites all attendees to take advantage of the opportunity to network with senior leadership. Don't be shy. The seating will be designated. You can read about it at the back of the room and find out where senior leaders will be seated. First come, first serve, your opportunity to share ideas and ask questions. The day will conclude with 2 special sessions. I remind you, one is Meet the Seniors session that DISA hosts in the registration lobby. This will be your chance to engage with DISA leadership in an informal setting. If you haven't been to it before, I'll tell you it's great value, and it's a great commitment on the part of DISA's leadership. We thank them for this commitment. Believe we get a lot of great conversations undertaken there. And we will have, for the first time, a small business speed dating session in rooms 340 to 342. That's facilitated by Ms. Sharon Jones, the director of DISA's Office of Small Business. Ladies and gentlemen, if you just take a short break, we'll be ready to go in about 5 minutes.